So before any calculations are done within MagiCAD, it's important to set your calculation standards. So they are held within the MagiCAD Common tab, Settings, and then Project. And what you'll see here is the calculation standards for pressure losses for ventilation, any sound level filters, and then we've also got our pipework settings here, and we have a few in there, and we also have in the domestic water we have all the market area standards, and same for the hot water, drainage and sprinkler calculation. But today we'll be concentrating on the ventilation and the piping. Also, what's important is having your systems correctly defined with temperatures, viscosities, etc. So how to find that out is if you click on any of your systems that you may have, then you've got your system classification should be correct, your fluid type, and then your fluid temperature. And these are added within your Revit template. The ventilation calculation within MagiCAD is an easy way to size and give a pressure for your system. It's also easy to interrogate the system once you've calculated it, so you can get accurate designs within your model and straight into your model with the model and ducts all sized. So to do that, I've got a little system here. One's got a fan with supply and extract, and then I have got a early stage design at the bottom, and this is using some of our calculation nodes. So if you don't have any families available, then what we can do is we can use these nodes to either use for future use or any fit outs, and all it is just a bit of a end of a duct that we can put this node on. I'll go through that now. So as you can see here, we've already got one on, and just to add that, it would be a case of going on this calculation control and adding a connection node to the end of a branch. So if I go into the sizing calculation now and click on sizing, as you can see there's no fan attached, there's no grills attached, and what I can do is I can size my system using these sizing methods that are created within our data set. So I'm just going to use a max pressure loss of 1 PA per meter at the minute, and I'm going to select this supply duct, and as you can see it's giving me a report. I've got levels, I've got nodes which are changes of direction, so the calculation you can find it on the calculation. I've got the duct series type and the series that are all set within the data set. I've got the products, and then I've got the sizes. This is a column for all sizes. So what you can do is if I right click on any of these, I can set a new duct size, but this was the previous sizes of the duct from a previous calculation. I've also got a length of each duct length in meters. If there's any insulation added to this ductwork, it would show me what series of ductwork would be on here. I've also got the flow. As you can see, the flow gradually increasing, and then I've got the velocity in each part of this. And this simple schematic here is just to help you find where you are on the system. But what's also nice is I can right click and highlight a model, and it will jump to that within the model, that branch. And also if I select anywhere on the model, it will jump to it within the report. So what you do get is if there were systems added to here, I could flick through the systems. I also get a general results page where it will give me some of the relevant information for the project. If I go back into here now, and you'll also see I've got a pressure drop per meter for each one of these lengths, and then I've got a sizing method that's used in each one of them lengths. If there's any warnings, it would come up in this warning selection here. and I'll come back to diversity in a sec. So once you press OK and update to model, you'll notice on here within the model it will actually go through and size my duct and correct the sizes and update any tags that you may have on there. So just to do that again on the extract system, again the same, I can pick a branch or a network. I can even set limits of my width and my height. So again, I can select anywhere on this system, and then I will again get this report that's bi-directional, and I can go in or out from the model and press OK, and you'll notice again it will then go ahead and update them sizes. Okay, so quite quickly you can get your main size of duct around the building. If there's any pinch points, then just by using these nodes, as you can see, I've got extract at 3 number offices at 45 litres a second for the extract, and then the supply, I've got again 3 offices at 60 litres a second, and then I've put in a lump sum of a pressure. Okay, and then if I move on to this system here, which is a bit later on in stages. So we've got a fan attached, so we've actually got a family for a fan, and then I've got grills attached as well, and they've got flows associated with them. So it's a similar system to the one below, but again what I can do is I can go on to size, and again I can give it a sizing method. I can lock my constraints, but this time I'm just going to select one part of this system and it will run through, and you'll notice I select the extract but the supply is on here, and then on the simple schematic we've got the fan on here, and what I can do is I can highlight that in the model again so it can jump to the fan. I can also show the properties of that fan because it is a MagiCAD family. We do have this dynamic data, and we do have the properties chart here, and same for the extract that we can flick through. And then I've also got a bit of a data on the manufacturing product code, and I can always go to the website. I can get the dimensions up. I can have a look at the fan as well. Okay, so if I just close that a second, and you'll notice now that I've got all the same information, but on this one I have the grills on here, and again I can right click, I can go on product properties, and we do also get the diagram for the grill, and I get to interrogate that as well. And then same again, if I go to the extract, there's a connection node on here for example, and it'll give me the litres per second on there and the velocity sizing method. So all the same as below, but it's a bit more detailed within the actual modelling. I can then press OK, and then it'll do the same as it did below. Obviously there's a lot more to go through on this one, so it's just updating that. And then again, it's gone through my duct length and it's changed and the size to suit the report. But what I can also do is if I go back into the sizing, and go back into the report, if I do need to change any of these sizes, I can click on here and on a length, and then right click and say set duct size. So say I wanted to make that a little bit bigger, and then it would lock it. I press OK, and then what I'd do is update sizing, and then it'll update the information through looking through that size. It'll also give me the old size that it used to be, and then once I press OK, update to model, it'll change the size on that duct. As mentioned, I can also add a diversity to a branch or any selected objects. So say I wanted to put say 75% on a couple of branches, I can go through and add which branches I need to add the diversity to, press finish at the top, and then go back into the sizing calculation and rerun that calculation. And then you'll notice now it's added a column for the diversity, and then it's brought my total total duty down. Okay, and once you press OK, update to model, it'll push all that data back into that duct. So the next step to this is then balancing. We do have a pressure drop calculation, which will just basically add up each section and each grill and each elbow and fitting just back to the fan without balancing. But for this purpose of this webinar, I'm going to use the balancing. So similar to the sizing calculation, I've got a calculation range of a network. I can set limits if I want to be warned if it goes over high pressures. I can also put a tolerance for my balancing. We've got three options here. We've got balance to minimum pressure, balance to fan pressure, and then balance to pressure defined in sensor. So that was within calculation control. But what I'm going to do here as well is I'm going to make sure that this is ticked. This will highlight my index run. I can also put margins on my flow and margins on my pressure. And once I press OK, and then select the system again, it will now do the balancing calculation. So this report is the same as the sizing report. What I can do is I can right click on the fan again, go to product properties, and as you can see it's now updated it to have the pressure on there as well, and same on the extract. And you'll notice here the highlighted green is the index run, so that would be my maximum pressure is on this length. And what I can do is I can right click and show this route only, and it will just show me that route. And then right click again, I can show all routes. Product properties again, and it will give me the data that is supplied within the grill and the graph that is provided along with it. On any fittings, I can right click and show pressure data. So what this will do, this is referring back to the data source that is set within the settings, and what this is telling me is the K factor from this fitting is derived from this flow, and that's the pressure drop. It's from this data source, and then this is the actual identifying table within the data source, and then it also displays the K factor, so you can interrogate the whole of the calculation. But with this balancing calc as well, you'll also get warnings where any of your grills or your system is not in balance. So as you can see here, I've got a warning. I can skip to next warning by using this button. But then if I use calculate resulting flows for unbalanced terminals and then update, you'll see here that this grill is 125% over its design duty. And as you can see, that here is the QV set. So this is your flow that we've set. So it was set at 20, but it's actually providing 25.1 litres per second. And if I go further down to the other grills, you'll see because this grill is taking most of the air and the duty from these grills below, so it's affecting downstream. So then you'll need to know to put any VCDs on the system to balance out this system. There is actually a VCD within this grill, within these grills, and this is where they are adjusted. So it's 90% adjustment there. But what you might need to do is go ahead and add more VCDs to the system to help equal the flow out between the whole of the system. And it's also gaining pressure here from the static pressure, where the system goes rises and drops. So it's taking and increasing the pressure as that happens. So I can press OK, update to model, and then all the data will be pushed into these ducts, and then any tags that you may have on will then be updated. Similar to the ventilation, sizing and balancing calculations, we do offer that in the heating and cooling as well. We also offer that in domestic hot water, but with these webinars being HVAC related, we're just going to concentrate on the vent and heating. So what I'm going to show you now is how to add these connection nodes. So these are in calculation control, and what these are used for are future use in buildings, and basically adding a load and a pressure onto a system so that we can allow for it within our sizing, but we might not have the architect's layout set out correctly, or this could be for a kitchen, for example, kitchen fit out, and the kitchen's done by a specialist. So what we do is cap our pipes, ducts off into the ceiling, but we need to allow for that load. So what you can do is, if I select the end of these two pipes, the flow and return, I'll then be given a connection node creation. So what I can do is I can put kitchen fit out, and then I can allow for, I don't know, it doesn't really matter what you put in, but I can allow for a pressure, a power and a pressure. Press OK on there. I could tag that if I want to, but in the interest of time, I'm going to leave that for now. So if I had any other branches, I could then start adding nodes onto there. And to change them nodes, all you'd have to do is select them and then come down within your properties, and you can see your powers in there, and so is your pressure. So now to use the sizing, I go on heating and cooling sizing. And then it's a similar menu to the ventilation. I won't go too much into it, but you can select your range, your sizing methods that are created within your dataset, and then you've also got your heat losses from your pipes. So you set an ambient temperature where your pipes are going through ceiling voids, for example, and then where available, it'll use a space temperature. And then you can also set a warning if the temperature decreases more than the specified amount that's here, which is 15 degrees in this case. Press OK, select the system. It'll do the flow and return together. This is a similar menu to the ventilation calculations. So what you can do in here is you can flip between supply and return, and you also get your general results, which are your project information, network volume, etc. You can also do a PDF or copy from a clipboard. What this is copying all this report and then you can paste it into Excel. If there's too many columns here, you can right click and take some of these off that you might not need, or you can add, and you can also move up or down depending on the order that you want to see. So if you press OK, you'll see they'll disappear. But what you do have is you have a size, an old size, you have the level, you have a simple schematic down here to help you navigate through the report. You can add insulation series if you right click, and you can set any insulation series that you might want. You will need to update sizing even if you add insulation, and same with the sizing, you can set a pipe size if you want to fix one. Okay, and then you'll get the power for each of the products that you have, and you can right click and see the product properties. You'll get the flow, velocity, then you'll get the temperature. As you said before, you had the heat losses, so we've got the temperature as it's going down through the system. And then we've got the heat loss in watts. And then we've also got the pressure drop per meter. And then any specified sizing method that's used. And then if there's any warnings, they'll appear in this column. And there was no warnings in this model, but if they were, I could go next warning and it jump straight to that warning. You can also jump to the radiators or any products or lengths from the report within the model, and you'll notice if I move this out of the way, it's jumped to that radiator, and the same applies from the model to the report. So I've clicked on that radiator there, and it's come over, so it's bi-directional. So once I press OK and update to model, it will then run through that system. It will use the sizes from the report and change the sizes on the model, so I don't have to go through and change pipe sizes or model the sizes. As you can see, it's done that there. And then what we can do is we can go to the balancing. So basically this is going to give you your pump pressure of your system, so you can go ahead and you'll have your flow and your pressure for your pipe, so it'll work out the index run. Again, you can select a balancing method that is set within the data set. You can set a warning limit for any high pressures. We've also got three types of this calculation for pressure. So if we had a fan on there, we could use this pump pressure. So that was an actual family of a pump, a MagiCAD one, or even third party. You can add this to the system and it will actually balance to the constraints of the pump. And then you've also got the balancing to feed point pressure, which you can just add a pressure here if you haven't got an existing pump, for example, but you know the pressure. So this one, balancing to minimum pressure, would just be adding up all the pressures from the system and then giving you a total pressure at the end. So basically an index run. Heat losses we've gone through, and then we've got this options at the bottom where it's highlight index run. So it'll highlight the index run on the model and the report in green. I can add margins onto here as well for the flow and the pressure. If I press OK, I'll then need to select the system again. I get the same report. I can do all the same things. I can right click on here as well on any fittings and go on pressure details, and then this will give me all the data that has been used from that fitting, for example the K factor, so any and it will also give me the data table and then the source where the table is. It'll give me the pressure and then the flow that is being used, and again it's bi-directional. But if I go onto this general results now, you'll see that it's given us all the project information, and then it's got the total flow, and then it's got the total flow including margins. It's got the total pressure in there as well, and then it's also got the pressure including the margins. It's got my fluid temperatures and all the information that I might want to see. And if I press OK, that'll all be pushed into the model and update any tags that are on my model, and then there's your heating pipework. And anything that changes now, all I would need to do is go back into the calculation and change that, whether there's any additions to it, and then I can rerun the calc and get an accurate and quick way of sizing my pipework. So once you've sized and balanced your system, you might want to print this report off. So what you can do is if you go into edit at the top of the report, so to get back into this report, what you need to do is size and balance your system again. We're on a heating system here that we've just gone through. I can copy to clipboard, where it will just basically copy to my clipboard and then go into Excel and then paste in this report into Excel. You will lose the little schematic on the left, but then if you go into print and print to PDF, then this is an example of what you would actually get. So as you can see here, we've got the title of the report, we've got all the project information, which is using the Revit project. Then we've got the information from the calculation with including date. And then we've also got the inputs values, viscosities for example, and balancing target pressure, air density, minimum pressure of devices, and any warning tolerances that may occur. And then you'll see here that you will be provided with the schematic on this one and your report below. You can also add your company logo here if needs be, and then the heating one there is just similar, but you get things like system volume, fluid densities, and the thermal conductivity of the pipes. Okay, thank you.